This video is intended to help you prepare for the design review that we're going to conduct this week on Wednesday, the 10th, during our lab, excuse me, or which you'll do at other times. So let's take a look and see what we'll cover here. We'll cover an explanation of note-taking styles, and then we'll discuss a little bit about what type of information may be of use. And we'll have a few things to say about that. So let's take a look. The information is in your presentation submittal, your submittal template for week 4. And you'll see here that we've got our design review prep. And that there are 3 segments that you're going to prep on. Material properties, cost, and then you're going to do a little bit on machining basics, which I'm going to cover in a different video for you. The main thing is you're going to talk about material properties. That's where you're going to have data. When we're talking about the other things, you're going to use your other background data, but you're going to need some more information here, and you're going to need some information here so that you can do your design review. You can be effective in the design review. So let's take a look. We have to talk about galvanic potential, thermal expansion, compressive strength, machinability, hygroscopicity. These are all things that can be important to any one design or other, and you have to have numbers to be able to back it up. So let's see what you can put together maybe to do this. Now I have what looks like a blank page here that I'm going to add my own notes to later on. But right now I'm going to look and see what some other people have helped me find also. So here I've talked about, because it's got my name on it, use similar metals wherever possible or use plastics. I remember that from last week, and I remember this chart. So now, what does that mean? Let's get into the chart right here and look and see. And it says aluminum alloys can be used alongside mild steel, austenitic cast iron, aluminum, bronze, or naval brass and bronze. And so if I'm going to use similar metals, I'll want to pick an aluminum or an aluminum bronze or a naval brass. Okay, I'm probably going to want to pick something in this area. I could decide to pick something down in the middle here. Okay. Or one of these, or maybe a nickel chrome alloy. If I'm going to use a similar metal, sometimes I want to use a set of materials that are all pretty close together. But here at least I have some information. What do you know? I've got something I can talk about. The next one to talk about, let's talk about thermal expansion. So here, somebody gave me some stuff in green. So let me zoom in on this. I talked with one of my colleagues, and they sort of got together and said, oh, look, I see where the temperature range is going to be. I see from this chart that I just found on engineerstoolbox.com that metals are somewhere around 0.00015 inch of expansion or contraction for every degree. So if I multiply that by 60, I get about 0.0009 inch. That's less than a thousandth of an inch. That's going to be negligible. When I look at PLA or ABS, I see that it's different. It's about 0.68 inch per degree, which will be 0.00. And don't go by these numbers, by the way. Okay. I'm not using necessarily real numbers here because you have to go look these things up. So I'm giving you an example of how you would do it. Okay, please don't go and just copy my numbers because if you do, they're likely to be wrong. Okay, so there we go. And that turns into 4 thousandths of an inch. And if I'm just screwing something together or locking it in place, that's not a big deal. But if I've got a sliding fit, you remember those O-rings, all of those tolerances were less than that. So that looks like it could be an issue for parts sliding inside my piston. Okay. And then another person looked at compressive strength. So for PLA, I found it was like this. I'm not necessarily going to use PLA. I might use ABS or PET or something like that. But I found its compressive strength, which you recall from kind of like concrete. This is actually not bad. Concrete is about 8,000 to 15,000 psi in compression, but 2,600 pounds per square inch. And if I have a 2-inch block, that's 4 square inches. This times 4. Wow, that can really take a load. And metals are over 5 times as strong. So I've got information. I can speak with numbers. That's important. Be able to speak with numbers. And then PLA, hygroscopicity, that is, it will absorb water even from the atmosphere. Just think what happens if you put it underwater. And I'm not sure that's a good thing to have this piece of equipment absorbing water if I'm doing water sampling. So that might be kind of an issue. I didn't look up ABS or any other types. So you can look those up. But this is your note-taking skill. Okay? If it's you that owns this, you can put comments right in here. If somebody is giving you information because you're collaborating, they're sharing what theirs looks like with you, just make a copy and put the notes in where there's colors. And then I would put a little thing down here that says like green was colleague 1, where you give them a name. Okay, and make that one say green. That way people know who did what. And or you can just put their name right in over here. Okay, and then yours, when you present it, you just see that. You don't see the rest of it. Okay, so this is a very, very good way to take notes. Okay, and I want numbers. When we do our design review, if you just make a statement and can't back it up with numbers, with physical principles, with conceptual ideas that are drawn from long-term proven experience, then you're not adding good information to our design review. So opinions are wonderful, but not in a design review. When we start talking about which is the most important, then your opinions will matter. So then the next one is raw material costs, right? How much does bronze, aluminum, steel, PLA cost per pound? Okay, and how much will get used? And purchase price. What's the cost for a 1/4-inch nipple versus a 1/2-inch nipple versus a 1-inch nipple? Let's see those things. Let's see if those costs will actually make any kind of a difference. And look, it looks like I've got a problem right. That's better. All right. So that's some note-taking styles. And you may, I put a announcement in here. You may collaborate on this prep work, and you may share information on each page with your colleagues. but you must author at least one item on the page, each page yourself. And you must indicate who the other author was. Okay, and so here's the example that you just found. Okay, so there's some there's a little bit of information there. Let's take a look now. I'm going to talk just a little bit more and then I'll be done with this prep. What type of information may be of use? Numbers by which you can prove your point. That's number one. That's general information to use in comparison analysis. This costs more. This costs less. This is stronger. This is weaker. This has more parts. This has less parts. General information to use in a comparison. This is heavier. This will corrode more easily than this one. Comparison analysis. Okay? So that's the main one that you want to prep with. But you might have some ideas already. Okay? I can make this in such a way that I can reduce the parts and reduce the cost by $14. Okay, well, let's see. First of all, what is your original cost of our design? If it's $15 and you're going to reduce it by $14, that's significant. If it costs $1,000 and you're going to do a whole bunch of work to change it by $14, that's maybe not so significant. So have some ideas in mind and then have some information that supports your ideas. Okay? And we're going to talk more about this on Tuesday, of course. But this is your video on design review prep. As always, if you have questions, sign up on the appointment schedule. Here it is. It's filling in. It's getting filled in slowly but surely. Feel free to add your name to this. Okay, so there we go. And we'll go over this in lecture. We'll go over this, but it will really help if you've seen this review prep ahead of time.